Now let's continue with infinite limits. So first we need to know these basic rules about the sign of infinity. So let's look at them. Positive infinity plus positive infinity is equal to positive infinity. Okay. Same thing, negative infinity plus negative infinity is also equal to negative infinity. When you multiply infinity with a constant, for example here a times positive infinity, this is equal to infinity. When you multiply negative infinity with a constant, it is equal to negative infinity. Okay, but in this case, for example, if this would be like minus a times minus infinity, then we should say that this is equal to positive infinity. So you should be careful with the signs when you are dealing with infinities. Okay, so here we have a over plus positive infinity is equal to 0, a over minus negative infinity is equal to 0. So number over infinity, its limit always equal to 0. It doesn't matter if it is positive or negative. This is very important, this rule, very important, and we will use this rule a lot. So let's look at this example. Here we have limit as x approaches infinity, 2 over x minus 4. So here, instead of x, we will put this infinity, right? So it is 2 over infinity minus 4. This is equal to 2 over infinity. Why? When you subtract this 4 from infinity, this 4 is nothing when you compare with this infinity. That's why it's still equal to infinity. And number over infinity, as you can see here, this is equal to 0, right? So why this is equal to 0? For example here, okay, when you start giving values to x from, for example, 1, 2, 3, 4, 5, 6 till infinity, okay, you will see that this denominator will get bigger. For example, when you give this, let's say x is equal to 1, it is minus 3. But when you give x, for example, 8, it is 4, right? As you can see, it gets bigger and bigger. That's why the fraction will get smaller. As this denominator will get bigger, the fraction will get smaller. And when it gets smaller, it means that it will approach to 0. That's why its limit is equal to 0. In this example, we have limit as x approaches infinity, 3 to the power of minus x plus 2 to the power of 1 over x plus 5. So here we have this minus x as an exponent, right? Not to make us confused, let's rewrite this again. So I can write that as limit as x approaches infinity. So 3 over minus 3 to the power of minus x. I can write this as 1 over 3 to the power of x, right? So plus 2 to the power of 1 over x plus 5. So here, this 3 to the power of x, I will put infinity instead of x. So when I put infinity instead of x here, it will be 3 to the power of infinity. So this is 3 times 3 times 3. This is infinity times. So this is very big. So this will get closer to infinity, right? So we will get here 1 over infinity. So 1 over infinity, number over infinity, its limit is equal to 0, right? So this will be equal to 0. So when it comes to 2 to the power of 1 over x, so when I put infinity instead of x here, this will be again 1 over infinity. So 1 over infinity is its limit is equal to 0, right? So this will be equal to 0. So 2 to the power of 0, that is equal to 1. So we have 5, it will be 5. Its limit is equal to 5. So our solution will be it's 0 plus 1 plus 5, and from it's equal to 6. Now we have learned that number over infinity is equal to 0. So what if you have number over 0? In that case, you have two options. Let's look at this rule. For example, here we have limit as x approaches a, 1 over x minus a to the power of n. is equal to infinity when n is even positive integer, and it has no limits when n is odd positive integer. So as you can see, when you put a here instead of x, you will get 1 over 0, right? So after that you will have two options. If this exponent is even and positive integer, your answer will be infinity, and if this is odd positive integer, then your answer will be no limit. So let's look at these examples. Here we have limit as x approaches 3, 4 over x minus 3 to the power of 2. So based on our rule here, we can say that this is equal to infinity, right? Why? Because it has exponent as 2, so 2 is even and it's positive integer, so we can say that this limit is equal to infinity. Why? Let's look at their left and right side to understand its logic. So when limit is as x get closer to 3 from the right side, okay, 4 over x minus 3 squared. So here when you take x values greater than 3, it will make here positive, right? So positive, and then it will go till infinity. Sorry, it will get closer to 0. So it's 4, 0 plus. Okay, so this will be equal to infinity. When you take its limit from the left side, okay, so you should think the values for x less than 3, right? So when you take x values less than 3, they actually make this parenthesis negative. But since you have this even exponent here, this even exponent, it will make it positive. That's why this will be equal to 4 over 0 plus, and this will be equal to infinity. So as you can see, these are equal to each other, and this is all equal to infinity. That's why we say that this is equal to infinity. Since we have here even exponent, it makes this whole fraction is positive. So when we look at this example, here we have limit as x approaches 5, 1 over x minus 5. So here we have actually exponent as 1, right? So 1 is an odd number and it's positive integer, so it means that there is no limit. So when we look at its limit from left and right side, let's see what happens. So limit as x approaches 5 from the right side, 1 over x minus 5. So this means that you will take the values greater than 5, right? So this will make it positive. So this will be equal to plus positive infinity. When you take its limit from the left side, 1 over x minus 5. So here you will take the values less than 5, right? So it will make here negative. So this will be equal to negative infinity. As you can see, they are not equal to each other, and it means that this does not, the limit does not exist. Limits with fractions. So let's start with simple fractions. So let's see what happens when we have simple fraction and how we find the value of its limit. So as you know, simple fractions, they're between 0 and 1, right? As you can see here, we have limit as x approaches to infinity, 1 over 2 to the power of x. So here 1 over 2, it's a simple fraction. It's between 0 and 1. So in this fraction, as x approaches to infinity, okay, the exponent is increasing, right? So let's say, for example, let's say x is equal to 1. When x is equal to 1, our exponent is equal to 1 over 2. When x is equal to 2, our fraction will be 1 over 4, right? When x is equal to 3, it's equal to 1 over 16, right? As you can see, as our x here, our exponent gets bigger and bigger and gets closer to infinity, actually the value of fraction, it gets smaller. It gets smaller, and it approaches to 0. Okay, that's why its limit is equal to 0. Okay, same thing also here. Limit as x approaches infinity, 2 over 3 to the power of x. So as you can see here, 2 over 3, this is a simple fraction. It's between 0 and 1. So let's say x is equal to, when x is equal to 1, it's 2 over 3. When x is equal to 2, it's 4 over 9. After that, it is 8 over 27. As you can see, it gets smaller and smaller, our fraction. So it gets closer to 0. That's why its limit is equal to 0. For example, in this one, let's show it on our number line. So 0 is here, right? So first, here when x is equal to 1, it's 1 over 3. And after that, it is 1 over 4. And after that, it is, as you can see, 1 over 16. You see, it gets closer to 0. So that's why when it comes to simple fractions, and when limit x is approached to infinity, its solution is always equal to 0. Now let's see what happens when it comes to compound fractions. So as you know, compound fractions, they are between 1 and infinity, right? They are bigger than 1. So for example, here we have limit as x approaches to infinity, 3 over 2 to the power of x. So this 3 over 2, this is actually greater than 1, right? So here our x, our exponent, when it gets to closer to infinity, it means that also our fraction, the value of our fraction, it gets bigger and bigger. Okay, so for example, let's give x 1, it's equal to 3 over 2. When we give x 2, it's 9 over 4, and then it's 27 over 8. As you can see, this gets bigger and bigger, and it approaches to infinity. So that's why its limit is equal to infinity. Okay, so let's look at this one. Here we have limit as x approaches infinity, 5 over 3 to the power of x minus 2. So x minus 2, it's equal to infinity. So same logic, 5 over 3, this is bigger than 1. So that's why it will get closer to infinity, and its limit is equal to infinity. Okay, so when it comes to compound fractions, we can say that their limit is equal to infinity. Let's look at this example. Here we have limit as x approaches infinity, minus 4 to the power of x. So here you should give values to x. Same logic. First, let's try. When I give x 2 or 1, let's start with 1, it's minus 4. And after that, it's when I give 2, it's 16, and then it's minus 64, and then it is 256, and after that, when I multiply this 4, it is minus 1024, and it goes like this, right? So as you can see, 1 positive, 1 negative, 1 positive, 1 negative, it goes like this. So these minus 4, minus 64, minus 1024, these are all getting closer to minus infinity, right? They are approaching to minus infinity. But when it comes to these values, 16 to 256, and like as you can see, these values, they are getting closer to positive infinity. So as you can see, they get closer to different sides. That's why we say that limit does not exist here. Okay, so you don't have to know a formula or rule in this kind of questions. Just try to understand its logic, and it's much easier for you to solve and enjoy the question at the same time. Let's continue with this example. Here we have limit as x approaches infinity, minus 1 over 2 to the power of x. So as I said before, you don't need to know any formula or rule when it comes to these questions. Okay, just start giving values to x from 1 and let's see where it goes. So when we give x odd values here, this expression will be negative. When we give x even values, this expression will be positive, right? So let's look at its odd values first. So let's say x is equal to 1, and then our expression will be equal to minus 1 over 2, right? When x is equal to 3, this will be equal to minus 1 over 8. So when x is equal to 5, this will be equal to minus 1 over 32. So is this getting closer to infinity or 0? So without this minus sign, we would say these values are decreasing, but they also have these minus signs in front of them. It means these values are increasing. But when I say increasing, they are not getting closer to infinity. Actually, they are getting closer to 0 because these are negative. When I draw my number line here, okay, 0. So minus 1 over 2, it's here. Okay, minus 1 over 8, it's here. And as you can see, we are getting closer to 0. We are not getting closer to infinity because these are negative values, and when they increase, they get closer to 0. So that's why they are getting closer to 0. Okay, so as you can see, a minus 1 over 8, we have minus 1 over 32, and we are getting closer to 0. So now let's look at its positive values. So let's say when x is equal to 2, this is equal to 1 over 4. When x is equal to 4, it is 1 over 16. And when x is equal to 6, the expression will be equal to 1 over 64. So as you can see, these are increasing or decreasing. They are decreasing, right? They are decreasing and they are getting closer to 0. Let's see it here. For example, 1 over 4. 1 over 4 it's here. 1 over 16, it is somewhere here. 1 over 64, it is less than 1 over 16, so it is somewhere here. As you can see, we are getting closer to, again, 0. These are now decreasing and getting closer to 0. So it means that when it approaches from left and right side, it gets closer to 0, which means limit exists here, and that is equal to 0. In this example, we have limit as x approaches minus infinity 2 times e to the power of x. So when you see this e, don't get confused. As you know, e is a constant and it's equal to 2.7, and it goes like this. Okay, it's just a constant number. So when it comes to our question, 2 times e to the power of x. So this is 2 times e to the power of minus negative infinity, right? So how can I rewrite this? This is also equal to 2 over e to the power of positive infinity. So here e, we said that it's 2.7 and something like, it goes like this. And 2.7 to the power of infinity, this is also equal to infinity. Okay, so since this is infinity, our limit becomes 2 over infinity, and number over infinity, this is equal to 0.